Okay, thanks for reminding to turn on the recording. Okay, now um, for regression, always when you see the word predict, then it's always the regression algorithm, and the label will be numeric for most of the cases. The second type of supervised machine learning is classification. So label is a category. So when you see a categorize the group of these group of patients or something like that, then that is called classification. Okay, so the machine learning type is regression, classification. Those two belong to supervised because we already know the labels there. So here, predict whether a patient is at risk or for diabetic diabetes based on clinical measurements. So so the clinical measurements will be the features for this particular classification algorithm that we are going to use, and the label is categorization, whether the patient will be at risk or not. So that means this one is like a this label will always be numeric, but this label can be like a group, like a categorization category, at risk category, low risk category, high risk category, that kind of stuff. So when you see the word categorization, you can say that classification algorithm can be used. The other type of machine learning is unsupervised machine learning. So this unsupervised machine learning, here you don't know the labels. The training data will not have any labels. It is unlabeled. That's why it's called unsupervised machine learning. And in this, the main type of machine learning that we use is called clustering. So group similar items together. When you have a case of grouping similar items together, that's when you use clustering. So for example, vehicles with similar emissions, carbon emissions. So and fuel efficiency characteristics are separated into clusters. You call them as clusters. So these three are let's say electric. So these three can be grouped together, clustered together, and these two can be clustered together. These two can be clustered together. That kind of scenario you will have um, clustering algorithms that you use, and you don't, because you don't have any label there, you use that's the type of machine learning is called unsupervised machine learning. Any questions here? Let me see the chat. Sorry. Okay, so okay, no questions. Okay, so let's proceed to the next one. Okay, model training and validation. Uh, okay, so for this one, for model training, first what we do is you have a data set, and in the data set, you will identify the labels if it is a supervised machine learning that you are trying to do, and you identify the features. So one is called the independent variable, the other one is called the dependent variables. So once you do that, if you have to clean the data set, you have to clean the data set. For example, if you have null values, sometimes you might want to replace them with zeros, or you don't want to use them in your model. So those kind of cleaning should be done. So after that process is done, then the first step that you need to do for model training and validation is you need to split the data into training set and a validation set. Usually what we do is, for example, if you have 100 rows in the data set, 100 rows is very less, by the way, for model training, but I'm just taking an example of 100 rows in a data set. If you have 100 rows in a data set, usually what you tend to do is you tend to use 70 rows for training and 30 rows for validation. Once you split the data, then what you do is you need to apply an algorithm. For example, if you are using a regression, if you're trying to, let's say, predict price of a car, then what you use is you use the regression, because it's a numeric label that you are trying to predict, and you use a regression algorithm. And if it is just one um, label that you are predicting, then you can use the linear regression algorithm. So once you do that, so use the algorithm on the training data set. Your training data set after splitting will have splitting of the 100 rows, you will have 70 rows, because you use the 70%, 30%, or you can use 75%, 25%, depending on um, your you can try different percentages, and then you can see how the model is performing, right? So once you apply the algorithm, then the trained model will encapsulate what it happens is the trained model will encapsulate the relationships in the data. Then you use the model to generate the predictions on the validation set, on the test data set. So this test data set you will use the model on the test data set. Why do we need to you do that? Because the test data set will contain the actuals as well. So that way you will get, in the final thing, you will get evaluation metrics to compare what is the predicted and what is the actual, and what's the difference between them. So once you do this once, so for example, you have done this, these 1 to 5 steps, you have done it with 70 rows and 30 rows. And if you are not able to, uh, if your evaluation metrics are not satisfactory, then what you do is you can go into 75-25, 75 rows and 25 rows, or 75% of your training data set and 25% of your training set. So repeat this until you attain a satisfactory model. So that is the process of model training and validation. Okay, so that is that in general. So far what we have done is we have just covered the basics of what machine learning is. Now the next lesson is Azure machine learning. Not clear. Okay. Ramya Krishna. What is not no clear? Okay, sorry. It might be other one. Okay. Now any questions so far? Okay, so let's proceed to the lesson 2 then. Uh, okay. Now let's see what Azure machine learning is. As you all know, Azure is a cloud platform, so it is a cloud based platform for machine learning. Okay, so cloud means you need an Azure subscription if you are doing it in Azure. There is machine learning in AWS and Google platform as well, but today we are covering Azure machine learning. So in the Azure machine learning, there is a Azure subscription, and then within the Azure subscription, you will create a Azure machine learning workspace. And within that workspace, remember in the Azure basics, we covered a little bit about compute. So we need compute for running the training models. So you will have compute, you will have jobs, you will create jobs, and you will use services. Of course, you will use data, and also then you will create using all of these, you will create models. So this is the in visual scenario, you will this is what is machine learning all about. So you will have an Azure subscription, and in that subscription you will create a Azure machine learning workspace. And so that means it's like a workspace where it houses all these compute, your experiments. It's called experiment. You create an experiment, and then you run the experiment, and when you run the experiment, that is when it will create a job. And to run the experiment, you need the compute. and you can store your own data, or for learning purposes you can use some sample data as well, and you can use services as well. So that is what is in summary what Azure machine learning is. Any questions? Okay, so now let's go to what is Azure machine learning. Okay, now Azure machine learning has three authoring tools. One is called the automated machine learning. One is called the automated machine learning, where what happens is you supply the data, and and you also supply the desired supervised model type. So supervised model type is either a regression type or a classification type, right? Supervised, remember that slide. Supervised models are regression and classification, and unsupervised is clustering. Okay, so you supply the data and desired supervised model type, and what Azure machine learning does is it runs a whole heap of models that suit that particular supervised model type. It runs a lot of algorithms against that, and then what it shows is it shows what the best model is. You can see what are the three best models. You can select from those top three best models, and then you can dive deep into it. So that is what is called that is what is called automated machine learning, because it automatically as long as you supply these two, data and what the supervised model type is, it will give you the what is the best model fit, and then you can use that. So that's why it's called automated machine learning. Now next one is, remember I told you three authoring tools. I'll show you all those. The next one is Azure Machine Learning Designer. To start off, people will start with this one because it's a drag and drop interface and easy to do the uh, for beginners. It is very easy to understand what's going on for machine learning pipelines in machine learning, in the machine learning phase. So what this is it's a visual tool to create a machine learning pipeline. We will be doing this, I think. So use a training pipeline to train and evaluate the model. So it will be, you will get the components here, and this is the workspace that where you can drag and drop the um, components, so that you see this is the data, and you are normalizing the data, which is like cleaning the data. Here diabetes data sample data is being used, and then the first step, remember, it is splitting the data into a test data and a train data. So this will be the train data and this will be the test data. So train data will be used in the train model, and here two class logistic regression model has been used. And then the next step after training is scoring the model, and once you score the model, here is where the test data set will be used. And this score model component will try and um, predict the values of the label, and then at the end you will have the evaluate the model. So this is very easy machine learning designer approach. And then so for training and evaluating a model, you use the training pipeline. So this part is just for training. Once you are satisfied with the model, then you create an inference pipeline to predict the labels for new data, because here you have just used the 70% 20%, 70% 30%, or 80% 20%, where you have already have the actuals and prediction. Once you are satisfied with the model, then you need to use with new data, right? So that's when you create a inference pipeline and then predict the labels for new data. And then once you're happy with that, you can deploy the inference pipeline as a service for other applications to use, so that they can feed in new data and then they get the predictions. So that is Azure Machine Learning Designer. Now let's go to the first lab. Um, I'll post the link in the chat. Okay, so hopefully everyone is ready to do this one. Okay, what was your question, Susan? What services? 1111. Okay, so your question might be related to. Let me check. This one. Okay, so external services that you use, like how I mentioned, once you create the model, you it, the so once you create the model, you need to expose the model to for other external services to use. So that's when you use this model and expose it as an API for other services to use. So that is the thing here. Hope I have answered your question, Susan. Maybe, yeah, maybe we will once we start doing it, maybe you will understand a bit more. Okay. Okay, so now hope everyone is in the lab instructions for automated ML. Okay, we will be doing automated ML for now. So again, what we will do is we will go to the Azure portal like how we have done, and this time we will create a resource called Azure Machine Learning. So let's go to the portal and home. This is where you will be, and let's create a resource. Resource, create a resource. You have to search not at the top but at the bottom here, and you are searching for Azure Machine Learning. Let me know if you want to have a break. 10 minute, I can give you 10-minute break, but yeah. And then choose Azure Machine Learning. Everyone here? Yes, okay. Now, very good. Okay. Now let's click on create. Now here you can see these 6 tabs. If you are creating Azure Machine Learning workspace for a organization, then you need to consider the networking and encryption, those kind of things. Now because we are just learning, we will just create the basics of it, and then we will just review and create. Okay, so the basics that you need to do is, again, I would create a new resource group. So I will call this as AML AI900 RG, and then okay, it should come as new. The reason why I am creating a new resource group is you can just delete the resource group at the time of deletion, and all the resources underneath it gets deleted, and they are housed in that particular resource group. Now you can name the workspace. Remember, you have I hope you remember the first slide that I have shown. What is underwater? What is Azure Machine Learning? You have the subscription, and then in the subscription you have the machine learning workspace, right? So that is what we are creating here. So you can name the workspace whatever you want to name it as. I'm going to name it as AML AI 900 WS as a workspace. And again, for India, choose Geo India West, and for all New Zealand folks, use as Australia East. And notice that once you choose the region and name, it automatically chooses to create the gives new names for storage account and key vault. So I would use the same thing, key vault, application insights, and container registry. For now, container we are not going to use any containers, so just leave it as none. And once you are ready, just hit the review plus create. So review once, everything. Networking, we are not, our workspace is public, and encryption type is Microsoft managed keys, and yeah, everything is, we have kept everything as default. Now hit create. Okay, while it is creating, let's go back to the instructions. So what we have done is we have created a resource, submitted all these, and review and create and create. So we have done 1 to 3 now. It will take a couple of minutes to deploy. After that, let's select Launch Studio number 4. Once it is created, we can do that only the after it is created, after the resource is created. So let's wait for a bit, maybe couple of minutes. Maybe let's give a 5-minute break so that everyone catches up. Let's catch up at 11:30, 11:23. So 7 minutes break. Let's catch up. I'll keep the recording as it is. Let's go grab some water. Shall we start? Okay, now let's go back to the instructions. We have created the Azure machine learning workspace. Okay, now we are in number 4. Select Launch Studio. So where the hell is the Launch Studio? Okay. So
Your
once your
voice is
deployment is complete,
your voice is
put
too
the
small.
resource.
Your voice is too small.
Here again, like how you have seen with the anomaly detector, you get an overview what the resource group is,
Indra, your voice is really slow.
what's the studio web URL, what is the keyboard, all these things are there. And if you come a little bit down,
Indra, your voice is too small.
sorry, I was not having the, yeah, I can hear you now because I was not having the headphone with me, so that's why. Okay, now can you hear? uh, Hope everyone went into the resource, and then you can uh, see the Launch Studio over there, over here down. Now click on the Launch Studio, and it will open in a different window where at the top it says ml.azure.com. Okay, so now this will take you to the home page of AML AI 900 workspace. That is the name that I have given. It will take you to your workspace. Okay, so now we have launched the studio. Now let's see what the other instructions are. Close any messages that are displayed. Now in Azure Machine Learning Studio, you should see your newly created workspace, which we have already seen. Now what we'll do is first, first we need to create the compute. We have heard a lot about compute, right? So in the Azure Machine Learning Studio, we will select this icon, and then we will at the top left to view the various pages in the interface, and then select the compute page. Okay, under manage. Okay, let's go and see. Remember I was mentioning you the authoring part of it. So we have 3 types, and then the prompt flow is another one which is at the moment in preview. these are the three main ones. So Azure Machine Learning Designer is the one that I was talking about, and this in this exercise we are going to do automated machine learning. So um, yeah, we will do the automated machine learning, but before that we need to go to um, machine learning studio. Select the menu at the top left. Okay, top left. So this one. Let's be in home, and here you go in new. See, when you go new, you have a lot of things: compute cluster, component, compute instance, automated machine learning job, and things like that in when you hit new, right? So um, use these pages in the left hand pane to manage the resources in your workspace. Select the compute page under machine. You can either go there, or um, under the manage you go to compute. Here also you can either go here in the new compute instance, or you can go manage and compute. So let's go manage compute, and here, because we don't have any instances, it's not showing. So yeah, you click on compute. Okay, next one is on the compute page, you select the compute clusters tab, which we are already in there. Compute we have compute instances, compute clusters, Kubernetes clusters, and attached computes. You can attach computes from other systems as well. Um, but this is where we need to be. Compute clusters will be the place where you need to be. And then in the compute clusters tab, here is where you need to add a new compute cluster. And yeah, okay, so we will use these settings. So let's first uh, create a, so make sure you are in the compute clusters tab, and then hit new here. Okay, location is, for us it is Australia East, and I think Siri, you will be in Geo India West. Okay, now location is the same as your workspace. Now virtual machine tier, because we are going to use this for automated machine learning, we need to make sure that these are the settings that we use. So it's virtual machine tier is dedicated, and virtual machine type is CPU. So let's go and check that dedicated CPU. That is already there. Okay. Now the next one is virtual machine size. Choose select from all options. You need to choose standard DS11 V2. So from the, it's already, I think it is already selected. DS11. It said. So select the first one. Otherwise, it's, yeah, memory optimized. I don't know whether you can, because it costs 20 cents per hour. I don't know whether uh, all of you can
Uh,
run this one.
Indira,
Yeah.
so we use select from all options, right?
So yeah, select from all options. This one.
Yeah.
Okay. Okay. So now click on next, and then compute name. Minimum number of nodes 0, and maximum is 2. Okay. So select N and give a compute name. So I will just say AML AI900 compute, COM, and maximum number of nodes 2, and minimum number of nodes is 0. Idle seconds is 120, right? And 120, and enable SSH. Do not enable that, and then select create. Okay, so it's let's keep the other settings as it is, and then just create. So now this is called compute. We are trying to create the compute power to run our machine learning model. So it's creating. While it creates, so what it does is compute instances. So compute instances and clusters are based on standard Azure virtual machine images. So uh, on Azure there are standard virtual machine images. So once you create that, it creates a standard virtual machine, and then the compute is run against that CPU. So that's what it is happening at this stage. And any questions? Okay. Okay, once that is done, okay, meanwhile, while that is being done, let's look at the bike rentals data set that we are going to use for this. Okay, so what it has is it has the day, month, year. MNTH is the month, year, season. Can you all see, or shall I increase a bit? Yeah, so season, which season is again number, everything is numbers. Holiday, whether it's a holiday or not, whether it's a weekday or not. um, Zero means weekday, what is the number of the weekday? 1 to 7. Okay, and working day, whether it's a working day or not. um, and whether it, and you have the temperature. um, I don't know what the A temperature is, humidity, wind speed, and rentals. Because these, so we are going to predict what the number of rentals, okay, number of bike rentals. This is, what is this called? Can anyone tell? In the in machine learning language, what is the column rentals called?
Label.
Well done. Yeah, that's label. And what are the others called? These ones?
Characteristics.
Yeah, characteristics of features. In machine learning terms, it is called features. So this is what this data set is what we are going to use to predict how many rentals will be there for a particular season, in a particular year. So we'll be passing these ones, okay? And yeah, this contains both uh, rental booking as well as the uh, weather information as well. So that's the data set. I'm just closing it. So now in the Azure Machine Learning Studio, expand the left pane menu, same thing, view the data page under assets. Okay, let's go into Machine Learning Studio again. Okay, in the assets, can you all see here underneath the authoring there is assets section, and underneath the assets section there is data. So in the data, uh, you will have sample data somewhere, data assets. There should be sample somewhere. Okay. Okay, because we have downloaded it, I think we have to upload it again. Okay, so hope everyone. Okay, I need to paste this. Copy hyperlink. Posting this in the chat so that you all download it. Download the CSV file. Don't open it. Everyone download it. Just give you 1 minute. Anyone still downloading? Okay, so let's proceed. So go to the data, assets, and then here you hit create. Give the name of the asset as let's say bike rentals, and you can give description if you want. This data set contains bike rental information. Type is, we need to give a type, tabular. Okay, data type is tabular. Tabular. Okay, here is tabular. Okay. You can also give web URL, but that's okay. Now click on next. Uh, shall we give, maybe I'll just give from web files probably. Okay, I'm just saying I'm choosing from web files and then click on next. And here you give the URL. So I will just copy what I've given from here. Yeah, and you can skip validation and then click on next. Okay, then after that, so we are in okay, now we need to give settings delimited comma UTF-8. Okay, now delimited comma UTF-8, and only first file has headers, skip rows none. Okay, all files have same headers, only first file has headers, skip rows is none. Does dataset have multiple? Do not select. Okay, because this dataset doesn't have multiple line data, do not select this one. Okay, now I think it is loading the preview. Let's wait a bit. Maybe we'll just review it. And let's say create. So this is going to take a bit more, little bit more time. Okay, now view your data set. So once the data set is created, it is pointing you to explore. Okay, so just go and explore the data. So number of columns is 13 and there are 731 rows. And these are the columns that we have seen in the Excel file that I have shown you. You can also go into profile and see for each column it's going to profile. Okay. So now next one is we have done the number 4. Now what we need to do is, now we have the data. What else do we need to run an automated machine learning job? Anyone can answer if you remember the slide that I have. Okay. So we need the data and also the supervised model type. Remember? So we need to give the model type as well for us to run the automated machine learning job. Okay, so now let's go to machine learning studio and view the automated ML page under authoring. So now, because now we have created the data set, now let's go and click on the automated ML. Okay, now once that is done, create an automated ML job. So here, new automated ML job. Go to under authoring, go to automated ML uh, link, and then click on the new automated ML job, because we haven't created anything so far. So just hit on that. Now, first thing that we need to do is select the data set. So this is the data set. So just make sure that there is a tick here, and then go next. So now we have selected the data set. Now configure the job. So we need to give some name. So I will give target column will be rentals, because that is the label. And we can choose the compute cluster that we have created earlier. And the tasks type here is, can anyone tell me what the task type is? So new experiment name is AI900 bike rentals. That's the name I have given. And target column, what's the target column? Can anyone tell me from the data set?
Rentals.
Rental.
Rentals, very good. Yeah, rentals. And select the compute cluster. Compute type is compute cluster, because that's what we have done. And once you do that, I think it automatically chooses the only one cluster that is already there. So everyone configured the job, I guess. I'll just give 30 seconds more. Now click on next. Now tell me, what is the algorithm that we are going to use? Is
Re-
classification right? It has automatically chosen classification. Is that right?
no, it's not. We have regression.
Which one is that?
Regression.
Very
Regression.
good. Yeah, it's regression, because we are predicting numeric value, right?
Yeah.
So regression. So that is the supervised model type that we have mentioned, supervised machine learning type. And then now hit next. Now select the validation. Let's see what the instruction says. Task is regression. Regression. Okay, so we need to have a look at view additional configuration settings. I think we will choose that. Go back and come down and choose view additional configuration settings. And here make sure the primary metric is normal root mean square error, and supporting models, choose random forest light GBM. That's what you need to. So here, if you click on, oh, that is blocked models. Uh, okay, you need to untick the use all support models, and that will change to allowed models. And then here you choose random forest. I'll just type random forest, and then click on that random forest. And training job time, you can give exit criteria. If the training job time is taking more than 5 hours, it needs to exit. And metric threshold is 0.085. So what I mean by metrics metric score threshold is, if it is 85% accurate, then consider the model, something like that. So exit criterion, it says 6 hours, let's change it to 5 hours, and metric threshold is 0.08, 0.85, 85, 85. Oh, 0.085. If a model achieves a normalized root mean squared error metric score of 0.085 or less, the job ends. Okay, it should be 0.085. Okay, and concurrency do not change. We don't need to change anything. And select the validation and test type. Validation type is auto, and test data asset preview. No test data asset required. Okay, let's save this one. Go next. Now here, validation type, we will use auto, and the test data asset preview, no test data asset required. Now finish. Now we have created the job. So what it does is the job starts automatically. Preparing to running. Okay. Not started yet. Plucky sheep. So the job has started running. Have you all got the notification that it's running? Now, because it's started running, you can go into the models. Under the assets, there is models here. So just go into that. And so if I go into this one, so this is the experiment that we have created, and the status is running. Yeah, we'll wait till the model, till this thing completes. View the models tab and observe as each possible combination of training algorithms. And yeah, can everyone look at the models tab here and see whether you can see any models that has been created? Model list. Hmm, Databricks. Not yet. Maybe because okay, let's see. It's still running. Setting up the run. Okay, now any questions we can discuss until the status shows completed. Okay, there is a models tab here. Even there it's not showing. Let's see. Setting up the run. It's not yet started. Is everyone waiting or anyone else behind? You can come off mute or post in the chat if everyone is waiting. Same as you. Okay. Setting up the run status. Okay. Yeah, I think we need to see the complete status and then go to the best model summary. So, yeah, it is taking a bit of a while because it's running against a lot of algorithms. Okay, let's discuss any questions. If you have any questions, now is the time because we are waiting. Let me know how many of you are uh, planning to write the exam. Raise your hands. Parisudha, yes, very good. Brave, three of you. Four of you, very good. What about the others? Swati, yeah. Ramya, okay. Who else? Others are not confident. Five, six of you, I said. So everyone else is sitting on the fence. Right. Shilpa, very good. Yeah. Mm, okay. Let's refresh this one and see. Okay, running featureization. That's why we were not able to see models yet. It's now running the featureization. Mm, it takes a little bit of time, but I think should be we should have the results soon. So meanwhile, I'll explain maybe what designer does. So for example, if I go into the designer of authoring tab, uh, you can view, maybe let's view the image classification which is already there. This is a existing one. If I go there, okay, so here the flow is, this is a drag and drop tool. So here you have all the components in here. So data in the, if you look at the data, our own data set is here. And if you look at the components, you have sample data sets. You have adult census income binary classification data set, automobile price data set, you have CRM appetency, labels shared, all these different data sets that you have. You can use flight delays data set. You can use these and try and do the experiment. So here, um, the data set used is animal images data set. And once that component is dragged, you will have convert to image directory. That's the next component that was used. And here, if we look at what, if you double click on that, you can see what the parameters are for that image convert to image directory. Use default output settings. Input mode is input dataset mode is read only input, and run settings you use a default compute, because this is just a, we are just viewing, there is no compute method that has been used. And here you can display the, you can add the timeout seconds and give everything that is needed. That component, what it does is it converts the uh, data set to an image directory. Okay, so after that, so in order for this component to read the data set, you need the connection from the data input to the input data set. Okay, and from there onwards, the step that was taken was um, split the image directory. Remember, you need to split before you apply any algorithms. That's the first step that you do in training a model. So this is split image directory. Let's see what the configuration of the split is. So what they have done is 90% they have used for training and 10% they have used for um, for testing. Okay, so the test data set will contain 10%. And now the trained data set they have included in the, okay, split the input data set into training data set and validation data set. That's what they have done. And here um, the algorithms that they have used is init image transformation and apply image transformation. So initiate the image transformation and apply the image transformation. And this is a bit complicated. Okay, sorry. I think this came out. Mm, okay, and yeah, they applied a PyTorch model. Oh God, something is happening. It's not maximized. Okay, they have applied a PyTorch model to train, and then the and then scored the model and then evaluated the model. So this is how they have done the image classification using DenseNet. Okay, so that's how you can, and then if you want to run this one, you can just configure and submit, but before that you need to create a compute instance and then submit it. If you didn't create a compute instance, it will prompt you that you will need to create a complete compute instance. Let's go and see what is happening. Yeah, so now model training is happening. Any questions? I haven't seen the chat. Okay, how to decide on which supported models to select? Okay, that one, there are a lot of cheat sheets available based on your scenario. So you can use, like how we have the types of model machine learning, types of machine learning, you have a cheat sheet for some scenarios, so you can fit those scenarios and then you can choose the models based on your scenario. So for example, for predicting binary, if you have a yes or no 0 1 relation, so you can just use normal regression. uh, and if you have continuous variable as your label, then you can use linear regression, so something like that. So you can use different algorithms. There is a cheat sheet that is available. Maybe I'll find that cheat sheet and share that with you by the end of this course, maybe end of tomorrow or something like that. So now it's saying model training. So let's go and see in the models. So now if you go into the model tab, see it's using standard scalar wrapper random forest and max absolute scalar, standard scalar, max absolute scalar, and random. Yeah, these are the things that it has used so far for training. You can keep refreshing and it keeps on adding all the models that it is being used, and it is normalized, it gives the normalized to percentage as well. So, and what is this 100% sampling is done. Yeah, it's not showing responsible AI and explained all those things yet. So again, let's go into overview, and yeah, still going on. So okay, so that's designer. Any questions around designer? I will go through again. Um, let's take something. Okay, let's do this one. This is very simple regression automobile price prediction. So here it has automobile price data. You can view the data set, right click on it and preview data set. And once you do that, what happens is you can see how many rows are there? 205 rows and 26 columns. And if you see here, there is normalized losses with lot of nulls or nans not available. So you can eliminate this column entirely. So this is called cleaning of the data set. So it has symbolizing, it has make, fuel type, uh, fuel type, body aspiration, number of doors, body style, all these, and your label is for this is price, because you are predicting the price. Okay, so that's the data set, and it is one of the sample data sets. And the next one is select columns in the data set, because you want to remove the normalized losses column because it doesn't have much data. So that's the component that was used. It was just dragged from here. So if you try and type select columns in data set, uh, you will get select columns in data set. So you just drag this column, this component into here, and then after you drag it, you just connect from the data set to this one, so that you get this one. And after that, what you need to do is clean missing data if there are any data missing. So let's look at the uh, configuration here. So include all columns means this all columns exclude the normalized losses, because this is connected to this data set and not that data set. So, and what we are doing is, if there are any missing values, maximum missing value length is ratio is 1. So remove the entire row. If there is one missing value, remove the entire row. That is the cleaning mode that we are using out of these ones. Replace it with, you can sometimes, depending on your values, you can replace it with mean, median, mode, or anything custom, any other substitute value. But here at the moment we are using remove entire row. That's the clean missing data. Once you have cleaned everything, you have the right data set, then the first step in the process is split data. So here, the split rows, sometimes you can split columns as well, but that's not the way to do it, because you need all the rows to be used. So you are splitting the rows into here. The split is randomized split is equals true, and you are splitting the data set into 70% and 30%. Uh, you just define the 70%, so this will get to the training, the remaining will be remaining will be test. And that's the split data part. So once you split the data, this observe this component, this will have two outputs. One is the trained data set output, the first one, and the second one will be the test data set output. And here we are using the linear regression algorithm. This doesn't need a data set here, because this is just an algorithm, and you are applying this algorithm to the train model, which will receive the train data set from here. So this has two inputs. One is the algorithm input, and that's the data set input, and the output will be a trained model which has only one this thing. And that uh, uh, after you train the model, you score the model, and the trained model will be the input for the score model, but the test data will be the input for the score model, whereas the train data will be the input for train model. And after you score, you evaluate. Just remember these steps: split, algorithm, train model, score model, and evaluate model. And once you run it, you get the metrics, but because we didn't run it, uh, yeah, it will not show the metrics. Let's now go back to our automated ML and see. Automated ML confirm. Okay, go back to our this thing. Okay, now it says completed, and there is a warning: user specified exit score reached. Oh, okay, hence experiment stopped. Is it the same for you all? Okay, so the reason why it exited is it has done enough algorithms, and it has reached the algorithm where we specified the 0.085. Okay, so that's when it has gone and exited. Now it says that random forest standard scalar wrap is the best. um, yeah, where the normalized root mean square error. Okay, let's go and review this. Okay, so here you will get the best model summary under the algorithm. So let's go and in the overview, what is your best model summary? See, output name of the best model summary is this one. And then you can view all the metrics. If you select this one, you can view all the metrics there. So it says created on, and where are the metrics? Artifacts, jobs, just sets, explanations, preview. This is all preview. Responsible AI data is by rentals details. Under the model. Okay. So if you go into the models, sorry, not this one. Automated ML, go here, and if you go into the models view explanation, so this is the it is explaining the first one. So here you can see here you can see the metrics, top 4 features by importance. What are the top 4 features that are important? Working day is there, temperature, average temperature, I think this one, and this one is year. So those are the 4 uh, top features that it has identified. And you can see all the that is the aggregator feature importance, model performance. You can see model performance. Has all of you have is everyone is everyone's run finished? Error occurred while loading pipeline graph. I think, yeah. Looks like this is a bit buggy, so yeah. And this is a box plot where it is showing the mean absolute error is 109, sample size is 731, mean squared error is 30, and mean prediction. You can edit cohort also here. You can learn some things here. The aggregate plots are there, and individual data points also you can, by individual data points also you can see. So that's what we have now the best model. And okay, so automated ML metrics. Do we have a metrics tab here? Yeah, you have a metrics tab here. So here you will have explained variance, mean absolute error, mean absolute percentage. What is the absolute percentage? Main thing that you need to look for is yeah, see this one, the last metric. This one is 91% confident, 91% accurate of all the models. So um, 91% means 91% of the time the prediction will be very close to accurate. So that's the metrics part that we have seen. You can go through it. And now we can, if you are happy with the model, what you can do is you can deploy a predictive service. So let's choose the algorithm, and then I've already chosen. Now deploy, you can deploy it. So on the models tab, select the deploy button and use the deploy service. Okay, so on the model tab, see here you have deploy. You can deploy and deploy to web service, and then give a name, AI900 ML deploy. Uh, and then you can give a, okay, now here you have to create a AKS compute. So maybe we can just say, okay, there is a AKS means Azure Kubernetes Service Compute. For models to be in production, you need the, you can't use the compute cluster that you have created, but you need to use the Kubernetes cluster. So that's why it is asking for Kubernetes cluster name. So I'm just giving a KS AI900. I'll just do that, and then I am going to deploy that. So okay, so name, compute type, enable authentication selected. Okay, you can enable authentication. Token based authentication enable. Okay, so no code deployment, we don't need that. And okay, we need to search computer. Okay, okay, so we need to create a new compute. So anyone remembers how to create a new compute? Can anyone tell me where I can find?
Under manage.
Yeah, under manage compute. And see here there are 4 types. Compute instances is only used when we are using the Azure Machine Learning Designer. Compute clusters we use for automated ML, and Kubernetes clusters we use for um, new AKS compute is enough. There are 2 types under Kubernetes compute, AKS compute and Kubernetes compute. Create a new instance, and I'll just Australia East. Just choose Australia East, and just choose something standard. Yeah, maybe I will choose that, and then go next. Computer name is AKS AI900. I will just say production at this stage, and then I'll just create. I just did the basic. Let's see if it works. Once it creates, then what? Then you can choose that in the deploy. I don't know whether you all can create because you are under free tier, but just have a look at what I'm doing so that it's information for you. So it'll, hopefully this will create soon. Yeah. So after we deploy, then what we'll be able to do is we can use the endpoints of that. See in the model summary section, deploy and then predict rental service. So yeah, once that is done, once the deploy is done to succeed, then we can use the endpoints to predict. So we can use this JSON and then try and predict it. So let's see. Hopefully we will be able to do that. Um, Still creating, just couple of minutes. Any questions you can answer, you can ask. Okay, while we wait for that, maybe we will continue with our this thing. I think we have some. Um, so what we have done now is you use a training pipeline. No, no, not that one. So we what we have done is, yeah, we have done automated machine learning, and then we are trying to deploy the automated best model that it has suggested. Okay, so let's review these questions. You would like to train a model without labels that groups similar features together. What is this an example of? Container instance is used for if you want to containerize for production. But yeah, usually if we are just learning, we can just use the Kubernetes AKS, and then you can do that. Train a model without labels. Yes. Clustering. Okay, is clustering correct? Should be, because four of them answered cluster, right? So yeah. Now, next question is, an automobile dealership wants to use historic car sales data to train a machine learning model. The model should predict the price of a pre-owned car based on its make, model, engine size, and mileage, right? Now, what kind of machine learning model should the dealership use automated machine learning to create? So, because you will have the data set, what is the type of thing that you, when you saw in the next, when you hit next, you saw a list of algorithms, right? So, which one will you use? Will you use classification? Will you use regression? Or will you use time series forecasting? Oh, everyone answered regression. That's correct. Very good. Okay, now a bank wants to use historic loan repayment records to categorize loan applications as low risk or high risk based on characteristics like the loan amount, the income of the borrower, and the loan period. What kind of machine learning model should the bank use? Yes, classification here, because the keyword here is categorize. Okay, categorize means classification, and if it is without labels, it is clustering. And if you are predicting something numeric, then it is regression. Okay, so let's see whether our answers are correct. First is clustering, which all of you have mentioned. Second one is regression, and third one is classification. Okay, that's good. Um, okay, so that's summary. Before our summary, let's try and see whether we can refresh it. Still creating. It is taking a little bit more time compared to the compute cluster, but I think it's worth the wait. Let's see. 12:30. Uh, has anyone created AKS cluster? Tried to create? It failed. Yeah. Oh, it failed. Okay. Let me see if mine state is creating. Let's see. And what about others? Tried to, fell behind, so we'll get back to it later. Sure, sure, Shilpa. Okay. Um, let's give 3 more minutes and see. 12:30, right? Um, if it finishes, then it'll be easy for me. Otherwise, what I'll do is I'll just record that part and put it in the recording. Copy. I just want you to show how we can use the endpoints. So once that is created, you will have something in the endpoint, and then Let's go to manage. Still creating. And then you can test it. So let's go through the JSON file here. JSON file is a format where you can give it in and predict, like you are specifying the data here. So your inputs are day is 1, month is 1. You are trying to predict for this year 2022, season 2, and it's not a holiday, and it's a weekday, working day. Weekday 1 is Monday, working day, because it's Monday, it's working day, it's not a holiday. And weather is 2, point 3 is the I think temperature, average temperature is also the same, humidity, wind speed. You are giving all these parameters, and then you can hit on the test once you deploy, once you use that. Then you will get the test result as it will be the same 444. So that means what does this 444 mean? Can anyone tell me?
Rental price.
What is it? No, it's not rental price, it's number of rentals. What we are trying to predict is number of rentals. So on the first of the month, on the first day of 2022, at season 2, there will be 444 bike rentals. Okay, that's what we are, with the wind speed of this much and temperature of this much, all these factors, the bikes that will be rented is 444 number of rentals. Yes, yes, Corina, that's right. So that's what we will see once you test it. Let's do this. Yeah, it is succeeded. So let's see whether I can choose that here. I think I need to refresh it. Deploy a model. I'll just try again. Deploy a model, web service, as a web service. Um, AML deploy is my model name. AML deploy. And compute target is AKS compute. And now I can see my newly created compute. And here, uh, I don't think we can create, we need to choose anything else. Just deploy. Let's see the instructions for deploying. I think just choose normal. Oh, compute type is Azure Container Service instance. Okay. Let's try with this as well. Hopefully this will work. Okay, so I'll just deploy. Anything missing? An error occurred while deploying. Deployment request failed due to insufficient. Okay, so I must have chosen maybe, yeah, if I have to choose Azure Container Service, let's see. Yeah, I'll just choose Azure Container Service, and then okay, so now you can, deployment is in progress. Once that is succeeded, let's hope this will. Okay, now I understand. Somebody asked about container service. Let me see whether it succeeds or not. We'll give 2 more minutes. Otherwise, you get the idea, right? How to test the instance. So maybe we can cover it off tomorrow. Not this one. Any questions so far? Tomorrow I'll cover the computer vision and natural language processing, and I want to do more of practice assessments. So if you are interested in me doing a couple of hours only practice tests, I have a few questions, maybe about 40 questions. We can organize another time, maybe sometime next week, maybe for an hour or couple of hours, so that we can do that. So just let me know if you are interested in doing that. Then we can set up. I don't think we will have enough time for covering more practice questions. Okay, yeah, sure, yeah, yeah. We will organize something for next week. Yeah, sure, Sunny. Yeah, I will organize that. It's still running. I think we will stop it here, and then we will go through this tomorrow. The endpoint part we will go through this tomorrow. Does that sound good? Yes. Okay. Yeah. Let's do that. Start off with the endpoint thing tomorrow, and then we will cover the other sessions. And we will start at sharp 9 tomorrow. Is 9 okay, or shall we start at 9:10 like today? Because you might have 10 minutes to change. Oh, it took 10 minutes. Okay. Yeah. Yeah, okay. Let's start at 9:10. Okay, I will start at 9:10. Uh, yeah, I know, Ramya, so don't worry. I will send you, I will include you in the further communications. Okay, then. Um, yeah, see you all tomorrow. I'll stop sharing and also stop recording.